Okay, so today and tomorrow we'll be looking into the topic of research method for engineering. Okay, so you'll be previously you guys have looked into the introduction part and also literature reviews, right? How to do the literatures and literature studies. So now I will be looking into the important part, which is research methods. Okay, so for you guys to know what's actually the methods that need to be used in your research, right? So, so I'm Dr. Surendran from Faculty of Electronic Engineering and Technology, and also I'm a fellow from Advanced Communication Engineering Center of Excellence, ACE. Okay, so these are the topics that will be discussed in this topic today. So introduction, big ideas in engineering, block diagram, also design and specification, tools and procedures. Okay, so what is research methodology? Okay, the methodology chapter explain what you did and how you did your research. Okay, so you, for your thesis, you guys have five topics. I mean, five chapters, right? So first is introduction. Second is literature review. Third is research methodology. Fourth is results and discussion. And fifth is conclusion. Okay, so who can tell which one to start first? Anyone? In these five chapters, which chapter you'll start first? Hello, guys. Hello, are you guys there? Because I'm in full screen. I cannot see your screen. Guys, do you guys hear me?
Yes, doctor. Can hear you.
Okay, so I just need some response. Yeah. Okay, Fadzila said literature review. Okay, Fadzila, why literature review? Poinjitan also said literature review. Okay, uh, because if possible, try to turn on your mic and tell, because I'll be in full screen, so I cannot see your chat box. Okay, Poinjitan, why literature review?
So that we can understand the current and the past research activity and what are the research gap that we have, and also try to close the research gap with our problem statement and so on.
Okay, that's good. Okay, Fadzila, why literature review? Hello, are you there? It's okay. Just turn on your mic and just tell. Okay, it's okay. Never mind. Uh, so we'll look in why. Okay, so it's correct lah. So we'll start with literature review. Okay, so literature is the first part that you guys have to start in any projects, any research projects. Okay, so why we need to start from the literature review? Because you don't know, you don't know, because in your research project you are not sure what what kind of problem that you want to solve. Okay, what actually you want to do in your project? What are the objectives? Okay, so I want to solve this problem. Okay, first objective this, second objective this, third objective is this, you want to do this. All right, but why you want to do that? For the objectives you will say, to do this, to do this, right? So why you want to say that? Because you want to solve a problem, right? So where does the problem comes from? It's coming from your research gap. Okay, so where does the research gap, you got the research gaps? So from the literature. So so the flow of your any research project will start from literature. So you have to study, you have to do the literature first, you have to study the previous projects. So what are the projects that available, or what are the literatures that is already done before, it's already done before. Then from that you will be finding a research gap, right? Then from the research gap you have to mention the problem statements. Okay, these are the problems that is not have been solved yet, or the room for improvement. Okay, there are room for improvement. I want to improve this because in the previous projects they didn't focus much on this part, but this part is very crucial, so I want to improve it, right? So that are the gaps that you find from the literatures that will become your problem. And your objective of your project is to solve that, right? To solve the problems that exist, that is currently exists. So when you do a project, okay, when you do a project, so you'll be after coming out with the objective, then you have to come out with your research methodology. Okay, what kind of methods that you want to use to achieve the objectives? Okay, this method is suitable to achieve objective one, or you want to use a different method to use to achieve objective one. Okay, so that kind of thing that you have to see. So from starting from literature, then going to research gap, finding the research gap, then after that stating the problem statements. uh, then after that, from the problem statement you have to derive the uh, objectives. What kind of objective, what actually you want to do in this project. Then after that you go to the methodology part. Okay, so in methodology you'll be seeing the methods. Okay, we will be discussing about the methods that you want to use to achieve your objectives. Then after that, your results and discussion. Then you'll discuss your results and discussion, then you'll conclude. Okay, you already done your project, right? The next person comes, then he will look into your papers, then he will find a gap, okay, from your project. So it's keep on going on, it keeps going on, right? So that's why it's called as research. It never ends. Okay, because we cannot do everything, right? So that's why we have scopes, right? So we'll have a scope. Okay, after deriving the objective, you have to state the scope. Okay, I want to do this project within this limit only. Okay, because your objective must be very specific. So, and also why we need scope, because we want to limit within certain field area. Okay, so maybe you want to just focus on this material, or this topic. Okay, maybe this only you want to use this kind of algorithms, huh? Even although there are a lot of algorithms, so I just want to focus on this, right? These are the limitations, scopes and limitations. So within the limitations, you do this project. So the next person comes, he sees your project. Oh, this person doesn't use this method. Maybe I'll try to use this method and see to solve this problem to improve your project, right? It keeps going on. So the research never ends. So that's why we have improvements. Why we are technology is keep on improving because of research. Because they find okay that we can improve it, so they improve. So another person comes, okay, we can improve again. So it keeps on going on. All right. Okay. Do you guys understand? You guys can see the
Yes.
flow, the flow of your project. Actually, any project, any research project, it should be start from literature. Then you have to find the research gap. Then after that, you have to get the problem statements. What kind of problems that available exist that you want to solve. Then objective. So you want to solve what? You want to solve this. Okay, you want to achieve this with scopes, with this kind of limitation. Okay, just want to do this project, uh, maybe only with this limited area. Okay, so then what kind of method that's suitable to use, that can be utilized to achieve the objectives. So you use that. Then after that, you discuss the results and discussion and conclude it. So that's how you have to look into a project. When a supervisor gives you a topic. Okay, so this is how you have to. This is the flow, uh, uh, to do a proper research, actually. Okay. Okay, why we have so in the thesis we have 5 chapters, right? So literature is the first thing that you have to do. But why we have introduction chapter at the first? Who can say? Who can answer? Literature is the first thing that you have to do in your research. Okay, supposedly research literature review has to become the first topic, right? But why we have introduction chapter as the first topic? We have to introduce. We will introduce and we will discuss the problem statement. We will discuss about the objective, scopes and limitations. Why we do the introduction chapter first, then only we go to the literature review second chapter. Anyone? Poinji Tan?
So that we can slowly guide the audience into our thesis or our research area to help them to understand what are the backgrounds and what are the problems and what do we want to do with or what is the expected outcome and also the objective of our research.
Yes, correct. So introduction chapter is giving an introduction for the readers. Okay, if a thesis is read by any person, any person, so he can actually know okay, what are the topic about this, what are the uh, uh, what's I mean, like, he can understand, okay, this project is about what. Okay, so what are the problems, what do you want to solve, actually what do you want to do in this project. So he doesn't have to treat your literature review and all these things first. So he'll get some introduction first. So he'll be get introduced to the project. So that's why we have introduction chapter in the first as a first topic. But for you guys, literature is the first topic that you guys have to focus on. So don't write the introduction chapter first. Okay, introduction chapter is second chapter. I mean, like, after doing the literature review, you try to do the literature study first, then you do the literature chapter first. Okay, you write your literature chapter, you do the analysis, you find the research gap. Okay, once you find the research gap, then you analyze. Okay, then you do, okay, what is the problem statement, what is the objective, what is the scopes and limitations of a project. Then once you finalize everything, then you go to the methodology. Okay, what kind of method that's very suitable for this project that we can use to achieve, so that my project can be successful. Okay, so this is the method flow that you guys have to understand, because when you start with introduction, when you try to write your introduction chapter first without doing literature, you don't know what kind of research gap that is available. huh? What is the problems, that existing problems, you don't know. So how you want to write the problem statement and also objective, right? So try to complete your literature first, then only you go to the introduction, then go to the methodology part. Okay. Okay, so far, can you guys understand?
Yes.
Yes, Doctor.
Okay, good, right. Okay, so we'll look into a slide. Okay, so what is research methodology? Okay, so now we are looking into the research methodology part. Okay, after doing literature, after you got all the objectives and source scopes and limitations, then this is the methodology part. Okay, what kind of method that you want to use, to make sure that your project is done in a correct method. Okay, so the methodology chapter explains what you did and how you did your research. Okay, it's allowed readers to evaluate the reliability and validity of the research. So from the literature on the methodology part, we can know whether this person has used a correct method or not, a correct approach or not. Okay, we can evaluate your reliability and validity, whether that is correct or not. It should include the type of research that you did, how you collected the data. Okay, so you have to mention, so if you are collecting the data, so what kind of method that you use. Okay, or if you didn't mention, then means that, oh, maybe you can, maybe we can assume that you use your fake data, right? So how you analyze your data, the tools and materials that use in the research. Okay, the rationale for choosing this method. So you have to explain clearly why you are using this method. So in the research methodology, you have to show the flow chart. Okay, how you're going to do your project. So methodology part is very, very, very important. That's where you explain all your technical parts. Okay, what kind of technical things, theoretical, whatever theory that you have. Okay, whatever modification, whatever technique that you want to use, you have to mention in the methodology part. So by reading the methodology part, we can know, okay, this student actually used the correct method. Okay, he has modified the theory. Okay, the theoretical, you have explained the theory very clearly. huh? So that's the important part for the research methodology. Okay, the methodology section should be generally written in the past tense. Okay, what is research method and research methodology? What is the difference between that? Okay, research method is the objective of methods is to find solution to the research problem. Okay, for the research methodology, the objective of methodology is to determine the appropriateness of the methods applied with the view of a certain solution, a certain solution. So method is, it will be more focused. Okay, methodology is you are looking into the overall picture, right? So methods are just a behavior or tools used to select a research technique. So methodology is analysis of all the methods. So you have to see here. So the methodology is analysis of all the methods and procedures of the investigation. So you have to understand what is methodology. Methodology is it's looking into the overall, because in your project you might use, because you have three or four objectives, right, for your project. So you might use different methods. So methodology will analyze all the methods and procedures, whether these methods are linked or not, synchronized, whether it's that maybe when you after method A, is it possible to use method B? Is it validated to use method B or C? So that's the thing. Methodology comes from means. Okay, methods are applied during the later stage of the research study. Methodologies are applied during initial state of the research process. Means that you have to know the flow. That's why you have to draw the flow chart, right? So in the flow chart, you can see, okay, this is the first method, second method, fourth method. So when you draw the flow chart, you can see, okay, by using all these methods, I can achieve my objective or not, right? Oh, my slides doesn't change. In which slide are you guys seeing now?
Research method versus research methodology.
Okay. Uh, Now I already changed the slide. You guys can see the change, or still in the same slide?
It is still under research method versus research methodology.
Okay.
Now we can see that you go to engineering research.
Maybe I need to change. Yeah. Now you guys can see
Yep.
changing. All right.
Yep, it's changing now.
Okay. So this is what is research methodology, right? Okay. Okay. So research method and research methodology. This is the difference. These are the difference. The method is specific, very specific. So the methodology is the overall uh, picture of that of your project. Okay, the flow of your project. So methods are just behavior or tools that used to select the research technique. However, the methodology is an analysis of all the methods. All right. So it's an analysis of all the methods and procedures of the investigation. So methods are applied during literacies of the research study. Methodologies are applied during initial stage of the research process. So you have to before going deep into the methodology part, you have to you will have a flow chart. Okay, so you'll be doing your flow chart so that you can know, okay, this is the flow that you want to use for your project. So it comprises different investigation techniques of your study. It's a systematic strategy to find solution to the research problem. So methods encompasses of carrying out experiments, conducting surveys, tests, and etc. So methodology encompasses several techniques used while conducting these experiments, surveys, and tests. So this is the uh, difference between research method, and also research methodology. All right, so we have different methods, right? I mean, like different of research. So for in UNIMAP, mostly we are doing engineering research, and we are from FK10, okay, Faculty of Electronic Engineering. So we'll be doing engineering research. So engineering research have different kind of approach compared to other researchers like social science, business. So they have a different kind of approach for their research. So engineering research is based. So okay, engineering research is based on the principle of scientific research. It is based on the scientific method, which observation, experiments, okay, theories, calculations, all these things will involve in this engineering research. And models are derived from the existing body of scientific knowledge and verified independently by others who are experts in the field. Okay, so when you write a paper, so you'll be submitting your papers to the conference and journals, right? So when you submit your journal, it will be reviewed by the experts in the field. Okay, so the paper have to review by the scientific community, experts in the field, so that they can see whether this project is acceptable or not. Okay, so they will decide, okay, by analyzing all your methods that you use, your results that you got, okay, whether this result is correct or not, because the experts have to make sure whatever you publish, whatever you write, it will be used by another person. Okay, so it can be used by the industries. So industries, when they look into your papers, um, they can get some idea. Okay, so that's why paper is open source. Like paper is public. Okay, it's for public, so it is published for the public to read that paper. Okay, it's not patented. Okay, patented is something is it belongs to you. Okay, patent means it's belong to you, but publication means it belongs to public. Anyone can read your paper, anyone can see your idea, right? But if patented, it means uh, it is it's you know it's belongs to you. So anyone, if you want to get use that idea, means they have to approach you, they have to ask you. But for the papers, anyone can read, so anyone can get the idea and they can use their idea, right? So that's the difference between publication and also patent. So for academics like us, okay, we are in the research field, right? we'll focus more on publications rather than patent. Patent I mean, like the companies, industries, they will go for the patent. So they're not much interested in publications because they want to make sure that whatever the idea, the invention that they do should beneficial for the company, right? So they will make sure that it is patented and it is not used by others. So that's difference between academic and also industry persons lah, the research. So engineering research is based on precisely the same scientific method. However, the research is directed toward the practical applications of science to products, services, and infrastructure. So what are the big ideas in engineering research? Okay, most research starts with hypothesis. So you'll have a hypothesis. So means that you can do you'll have some idea. Okay, I want to do this. I want to innovate. I want to do some innovation on this topic, right? So you'll have hypothesis, that is statement. Okay, it is a statement which can be either proved or disproved. So you are not sure, you have idea. Okay, hypothesis is like idea, but it can be proved or disproved. All right, so that idea can be achieved in a correct method, or it cannot be achieved. It's not I mean, like it's not achievable, right? So when you have idea is like it is called as hypothesis. To prove a hypothesis, it is necessary to exhaustively examine every possible case and make sure hypothesis applies. So often this results in the creation of limiting conditions. The conclusion becomes slightly modified in that the hypothesis is valid providing certain conditions are met. Okay, even though at the beginning, at the initial stage, you can say, okay, I want to, it can be this can be achieved, this can be achieved. Okay, so by using this method we can achieve everything, right? But when you really study the literature review, getting the techniques, okay, then you finalize the problem statements, objectives, then so you will there'll be some limited because you have scopes and limitations, right? So it will be some limiting conditions. Okay, so only certain conditions can be achieved, right? So a full evaluation of hypothesis may take many years without a conclusive resolution. So that's why we can have any ideas. Oh, I want to do this, do that. Yes, of course, but we have limited time. For PhD, you guys have 3 years to 5 years, right? For masters, you only have 2 years to 3 years. So within that limited years, limited time period of time, what you can do, what you can achieve actually. That's why we need limitations, scopes and limitations. Within these limitations, scope, I will do this project. Although, even though there are rooms for improvement, although you have many ideas, oh, I can improve this, I can do this, I can improve this, but you have to make a stop. You have to make sure you put a scope. Okay, I just want to focus on this only. Let others. Okay, so when you all complete all your project, you publish your paper and you publish your thesis. Another person comes, oh, he can improve your project. It doesn't means you have to do everything. I want to do everything. No such thing. Okay, the time, the years, I mean, like the time still goes on, right? Thousands of years, a lot of innovations, from very basic thing, it's already improved, getting improved day by day, right? from mechanical part, mechanical comes to the electronic, then after that computer, IT, mobile phones, and all this thing, internet, everything is getting improved and getting improved day by day. Okay, it the time might take many years. Okay, it's already thousands of years, but it's keep on getting improved, right? So don't think that, oh, I have to do everything. No, if you think if you want to do everything, it will take many years, then you will be just doing your research only. Okay, so there are a lot of people that can improve your idea. Okay, so we do, when we give some, like for PhD, we have to come out with some novelty, right? For masters, doesn't mean you have to come out with your novelty. You can have a uh, improvement. Okay, improving the previous project. Okay, but a PhD, you have to propose a new technique or new solutions or new thing lah, novelty. Okay, so that's the thing lah, big ideas in engineering, right? Okay, so as I told you, relationship between chapter 1, chapter 2, and chapter 3. So as I told you, chapter 2 is the first part that you guys have to focus on. Okay, so we'll be studying on the theoretical background, right? So what are the state of art, current research that's going on. Okay, then you find the gap, right? So once you find the gap, after that you go to the problem statements, right? So from the problem statement, then you go to the objective. So objective, it should related to the problem statement. So make sure you solve, the objective is to solve the problem. So you say from the gap, so gap might be different research gap, then problem statement is different and objective is different. It's not related at all. You see, so you cannot do like that. You have to make sure gap, problem statement, objective, scopes and limitations are all related. You cannot have a different gap, a different problem, and different objective. So that objective and problem statement should be related. You should, the objective is to solve the problem. That's why you are writing the problem statements. You are stating the problem. Okay, we are having this kind of issue. Currently there is a problem in this field. Okay, so what is the objective? The objective is to solve the problem, right? You cannot write a different problem A, then you give a solution B that is not related to the problem. You cannot do that. Okay, so because I got previously I got read so many theses, right? So I will see some, the problems and objective are not related, and I see the research gap. Research gap is different. You find a gap, you already find a gap. Okay, find a research gap, but the problems you are stating is not related to the gap that you find. So what's the purpose of what's the purpose of doing the literature study? So literature study is to find the gap, right? So from the gap you find a problem. So then after that you solve that. So you do the project to solve the problems. So what are the objectives you want to achieve? So it should be related. Everything should be related to each other. Okay, chapter 2 theoretical studies, then after that going to the problem statement, then objective. So objective is to solve the problem, then after that you have to come out with some scope and limitation. Okay, so like for I'm from the communication engineering part field, so I'll be doing research in antenna. So for antennas, so we have a lot of things like different materials, substrate materials. So you can mention that, okay, I want to just use Rogers material. So but you can also use FR4, you can use different material. There are a lot of materials, right? But you limit your project. No, in this project, I just want to use this material only. Maybe another person comes, oh, this guy only used this material. I want to try with another material. That's will be his research. That will be his problem, his research gap. You understand or not? That is the gap that person will find from your project, because you only use this material, right? Material A. So let's say, for example, we have thousands of material. So you only use one material only. So there are rooms for use to different materials, right? So that person that he will find, okay, that is the gap he will find from your project. So then he will identify the problems and objectives. That's how the research keeps going on, okay, until now, and technology is keep on improving. All right. So then once you identify this, after that only you go to the chapter 3, which is flowchart, diagram, algorithm, tools and procedures. Okay. So methods. So method is the uh, can say the core of your project. So if you do mistake in the method, then your whole project will be a disaster lah, I can say, because the method should be very correct. You have to make sure that you use the correct procedure tools to do your project. Okay, so here, so for example, this is a example lah. Okay, so we have lot of categories, right? Okay, different categories. So you have to make sure that which method, okay, which method that you want to choose actually. So just now, as I told you, for antenna, we have substrate materials, right? I mean, like, so for this, we have different methods, right? So this is optical multiple access technique. So let's say, for example, you choose this one, okay? So you want to use novel FCC code, but there are a lot of things. I mean, like different methods also can be used, right? But for your project, you find this is suitable, then you'll be using this. Okay, maybe another person comes, he can try to analyze using this because he finds, okay, this person only use this method, right? So that's become a research gap for that guy. So he says, okay, see, we have a lot of other methods also. So he will try to use different methods. Okay, so that's the thing. That's the thing that you guys have to understand. So you have to, when you do a project, you have to make sure that, okay, so I do this project, I will give some. There are gap. You have to understand that, okay, there are some gaps that can be improved. Okay, that can be improved by another person. When you do a project, so you think that, don't think that, oh, I have to complete everything, I have to make sure everything is covered. No such thing. Okay, so while you're doing your research, you will know, okay, this is the gap, can be improved. So you don't try to solve that, let others to solve that. Okay, you just focus on your method and on your topic. Okay, so this is an example. Okay, so this is an example of the flowchart, right? So once you identify, then after that, this is the flow of your method. So how you're going to achieve, what kind of method you want to use to achieve your project, your results. Okay. So we'll take a break, small break, maybe a 5 minutes break. So we'll continue back at around 10:30. All right. Okay. We'll take a break. Huh? Okay, so we'll continue. Okay, so next we look into this design complexity. Okay, so for engineering research, you guys should have complexity lah, design complexity in your project. You cannot have a simple project, right? This project should have some complexity so that you can defend in your Viva. Okay, so I have this kind of complexity in my projects. It gives some improvement compared to the previous projects. So student has to deal with many components, right, or design parameters to complete the project. So it doesn't that you have to focus on. You can, I just want to use these simple things. It cannot be like that lah. Should have some complexity. So the design specification are set to be higher specification and excellent values, which has some excellent values. So how to report a design? Okay, maybe it can be circuit diagram. For electronic students, you can have some circuit diagram. For simulation, by using the simulation or and flowchart. So so report what have been done. Okay, so the solution and methodology are innovative and creative, shows excellent logical approach and well laid out design. So these are the things they have to make sure. So the report what you have done actually. Okay, so don't include whichever is that is not done in your project, right? And you have to make sure that it is logical. That's why uh, before publishing, we submit for review, right? Okay, it will be reviewed by the reviewers, experts in that field. So if they find okay, this is not logic at all, you know, you shouldn't use this kind of method to achieve this. So they will reject your idea or your paper. So it should be logical. It should solve a problem. Okay, show some different from other solutions, and solution is working, right? So you have to make sure that all these things are achieved, included in this research methodology. Okay, so what is the rubric? What you need to make sure that your methodology is very very excellent. Okay, so you have to make sure that for design complexity, so there are some rubrics that you guys have to follow. Okay, so you have to make sure that design complexity is excellent. So which one is considered excellent? So student has to deal with many components and design parameters to complete the project. So the design specification are set to be higher specification. Okay, so this is considered excellent. So for poor, only single component or on design parameter to design to complete the project. All right. So this is for design complexity. So how about the innovation? Okay, innovation, creativity, and project approach. So for very poor state, the solution and methodology shows no logical approach. Okay, no creativity and no layout design. So this is for innovation part. So for excellent, the solution and methodology are innovative and creative. So you have to make sure that the solution that you give, the methodology, it's innovative, some sub, because that's where you have to prove your improvements. Like for masters, you prove your improvements, right? Like you improve these some things. For PhD, you propose a new solution, a novelty. So it will show how innovative and creative, shows excellent logical approach and well layout design. So this is for innovation part. And tools and procedures. So for very poor, tools and procedures are quickly identify uh, no or inappropriate differences used to inform. Okay, so tools and procedures are not identified, no or inappropriate references used. Okay, this is for poor state tools and procedures. So for excellent, tools and procedures are clearly identified, okay, comprehensively explained and rationally justified. So numerous appropriate references sources from the wide range of source are used to inform your project approach. So means that uh, if you want to use some techniques or procedures, you have to make sure that uh, you have some valid reasons or citations. Okay, citations. Okay, saying that okay they have used this technique before, so I want to use this technique and try for my project. So you have to make sure that you have a valid reason why you're using that approach or why you're using that method. So if you're coming out with a new method, new new methods, so you have to theoretically prove that your method is correct. uh, so that's what you have to make sure. So that's considered excellent lah. Okay. Numerous appropriate references sources from wide range sources are used to inform project approach, right? So for the flowchart design, so it's like not logical at all. The flow of the project. So excellent illustration and very good explanation of your flowchart and diagram. Okay, so for the flowchart diagram algorithm, it should be it should be excellent illustration and very good explanation. So it should be logical. Okay, it should be solving the problem, following the standard notation, and also clear and easy to read. So you'll have also a Gantt chart, right? So make sure. So Gantt chart is like for you guys to make sure that the flow of your project. Okay, you want to achieve what? Okay, you want to achieve milestones. Your milestones. So consistent with your activity or flowchart. So you have to make sure the flowchart and your Gantt chart is actually tally. Okay, so it doesn't mean that you in the flowchart you show different things, and the Gantt chart you mention different things. Okay, so it cannot be like that lah. So you have to make sure that Gantt chart. So whatever you put in the flowchart, so you want to do, okay, you want to try this method, then after that you go to the second method, third method. So in the Gantt chart, you have to show the milestones. How how long you take to achieve the first method, to do the first process. Then how long it will take for the second process. So you have to make sure that the Gantt chart and also uh, the flow chart is consistent, is tally, right? So no need for details. Just describe by phrase, and also detail can explain verbally. All right. So next is for like using block diagrams. Okay. So this is an example of the block diagram. So block diagram is a fundamental way. So block diagrams for electronic students, we'll be having some block diagrams for computer engineering students also. So diagram is a fundamental way to describe overall systems, okay, while illustrating their workflows and process. So a clear picture of information or control flows. So you have to make sure you clearly identify your of the block diagram of your project. So let's say, for example, this is the transmitter. Okay, this is a transmitter. So in the transmitter, you have to make sure you have amplifier, right? So this is the baseband signal. You have modulator. Then after that, modulator carrier. This is power amplifier. This is antenna, right? So you have to make sure everything is complete. Okay, so it is logical lah. So a block diagram of transmitter is, if you, let's say, for example, you miss this, right? If you miss this, it's considered non-logical because you need something here for the modulation, right? So the modulate, it will modulate two signals. Okay, one is from the oscillator and one is from the uh, voice or something, the source, another source. Okay, so modulation will happen with two signals. So if you didn't give any signals to here, you just draw this, so it's not considered logic, right? This is an example I'm showing you. So you have to make sure that when you draw the block diagram, it is logical. Okay. So what is the research step, right? What is the research step that you guys have to follow for the research methodology, right? So first thing you should ask a research question. Okay. So what are the what do you want to achieve actually? Okay. What are the objective? Uh, what are the techniques? What are the objectives that you want to achieve for your project? So these are the research questions that you have to ask whether uh, what kind of method to use, what kind of approach to use. Okay, these are the research questions that you should ask first. Then after that, from the research question, from the objective that you finalize, you have to select your method, right? You have to select your method and the sample selections, what kind of samples that you want to use. Okay, let's say, for example, you want to draw a circuit, or you want to write an algorithm. Okay, so you want to improve something in your algorithm, you want to modify your algorithm, or you want to use that algorithm to improve something. So you have to make sure the method selection and the sample selection is correct. Okay, then after that, once you identify everything, you finalize everything, then you implement that. Okay, then you collect the data. Okay, so the data collection part. So data collection part is like for artificial intelligence, those who are doing research in artificial intelligence, and also some how to say, like you want to collect some data, right, to analyze whether your your method your method that you use is correct or not. You want to analyze that, so data collection is very important. Then after that, once you've done data collection, you'll go to the data analysis and presentation part. So this is the flow, okay, just a step that you have to follow lah. So once you identify the objectives, right, finalize the objective and the scopes and limitations, So you have to make sure the method that you select is correct. So you have to make sure. Okay, so this is for method. So for objective A, objective 1, so this is the method that you want to use. So for objective B, this is the method you want to use. So there are different that might be different methods to achieve all your objectives, right? Then after that, uh, so once you are once you finalize, then you use that method to build your circuit or algorithm or anything, to do your simulations and everything. Then after that, you do the data collection. Then you analyze the data. So once you analyze the data, you get the results. You publish the papers. Okay, you submit the papers for your review lah. So once they review, the experts review, once they accept, then it will get published. Now this is how this is a flow of your research method. So you have to make sure the method you use is correct. Okay, if not, if the method is wrong, then you collect the wrong data, and when you do the data analysis, then it will be everything will be wrong. So you have to repeat back. So you have to repeat back from here. So you have to do another method, sample selection, data collection. You have to repeat. So you have to make sure. So don't waste your time. Actually, make sure before you start your project, you have to make sure whether it is logical or not. Whether it is must be should be logical, solve the problem. Okay, it should have some difference from the different other solutions. Okay, so solution should be working lah, right? So you have to make sure.
Doctor?
Yeah.
Yeah, doctor, just wanted to ask if we have done a certain amount of literature review and we decided to publish a paper based on literature review.
Yeah.
Based on literature review itself, only there's no research work, but only literature review. So does that kind of paper considered as part of the contribution to our study, PhD study, for example?
Yeah, it can be considered because you are doing a review. It's called as review paper. So actually, a lot of people they prefer a review paper. Even you guys can approach a review paper as well, because in review paper they will summarize all the papers that they read, like you are doing, right? So like you will read
Yeah.
all the papers and you will summarize and put it in the review paper, right?
Yeah.
So review paper is very good. That is the first thing that you have to do lah.
Okay. Thanks. Yeah.
First paper that you have to publish, if can. It's not necessary, but if possible, you can publish a review paper. So it will be good for you to summarize all the literatures that you've done. Okay.
Thank you.
All right. Okay. Okay. So once you are, so we have to make sure that the sample, okay, the method that you select is correct. Okay. So supervisor. So that's why we have supervisors lah. Supervisors, co-supervisors to guide the students whether the student is using a correct method or correct technique or not. Okay, because the student might think, okay, this is the correct approach, but it might not be working. So the supervisors can advise, okay, you try to use a different method and see. So that's the thing, right? So this is the flow chart example. All right. So for the flow chart, you guys can have different phases, right? So like say for example, you have 3 or 4 objectives, right? So to achieve that a project, to achieve the objectives, you can split your flowchart into different phases, right? So this is like for first phase, you'll be doing that method. You'll be using that method to achieve first objective. Okay, and second, for the second phase, so you'll be using these methods. Okay, you'll be using this method to achieve second objective. So for the third phase, you'll be using these methods to achieve the third objective. So you can split the uh, flowchart. Okay, you can categorize your flowchart into different phases. All right. So you will understand lah. You will can clearly understand, clearly identify. Okay, first phase to achieve first method, first objective. Second phase is to achieve second objective. Third phase is to achieve third objective. So it will show a clear path, a clear flow of your project. Okay, so let me show simple design. So this is my thesis lah. This is my thesis that I wrote. Okay. So you can hear, so you can identify. So this is the flow. From here you can see these are the flows, right? So you can see. Okay, first I do the problem literature review. Okay, then after that doing the methodology part. Okay, simulation, feasibility. Okay, and all these things. Then after that fabrication and also analysis. right? So for the flowchart, you can see here, I split into two phase. Okay, phase 1 and phase 2. Okay, here, see, so this is the phase 1 and also this is phase 2 lah. So you can see what kind of what kind of approach that I'm using from the flow that I showed just now. So we can split the flow of the project. Okay, this is the overall flow lah. Okay, this is the overall flow. So then after that, I'll show a very specific flow chart. Let's say, for example, for this design, okay, I show this very specific flow chart. Then after that, for each design, I show a very specific flow charts. Okay, so you will have a overall flow chart. Okay, overall flow chart. Then this is the, as I told you just now, research methodology and research method. Okay, so research methodology will see the overall flow of your project. Okay, from start to end. Method is, this is the method for each design. Okay, what kind of method that I'm going to use? Okay, so I will be very specific. So what I want to do in that part actually. Okay, so for each so it's up to you lah. It's up to you how you want to do your project. Okay, based on your topics, right? Different topics, you'll have different topics, so you can decide what kind of approach methods that you want to use in your project. Okay, so you can split you can split your phases, your part to different phases to achieve that objective 1, objective 2, and objective 3. So why do we analyze data? Why we need to analyze the data? So the purpose of analyzing the data is to obtain usable and useful information. So the analysis is irrespective of whether the data is qualitative or quantitative. So for engineering, we'll use the quantitative way lah. Okay, quantitative data. So why we need to do analysis? Because you have to make sure that whatever data that you collect, whatever results that you get, it's correct. Okay, so you have to make sure that this is the results that you want. Okay, if it is not, if you're not getting the correct result, then you have to look back into your techniques. Okay, the methods that you use. Maybe you have to change the technique, or you have to change the approach that you use. So you have to do back again lah. Okay, so sometimes like for example, for my case, right? For my case, okay. So for my case, actually, I did a mistake at the beginning. Okay, so I thought that method would work for me. Okay, so I used then after that I tried that method, but actually that method doesn't work, right? So what I did, I do some analysis. I look into the theoretical explanation. Okay, theoretical explanation. Then after that, I find that okay, I need to modify the formula. So then I come out with my own formulas. Okay, so so when I start with this project, right? So I start with a simple design, then I improved. Okay, I improved a bit. So I did some research in antenna. Okay, I improved. Then after that I tried to improve again until I achieved my goal. Okay, but what happened actually in between, I got stuck. I couldn't go further because of some things that lacking. So I couldn't know what is the issue actually. So I need to do some very thorough analysis lah. Okay. Uh, so I looked into all the formulas approach. Okay. Then after that I do as analysis. Then once I find, then after that I come out with my own formula. Okay, I proposed a own new formula. Okay, I modified that formula. Then by using this is the proposed new equation. Okay, so by using this method, then I continue. I try to continue my project. Then after that, I can get the results actually. Then I continue. I start to continue my designs. Okay, so for that's why I'm saying for different method, we have to make sure that you really understand. If you want to modify something, you have to make sure that you understand the formula and theory correctly, because you might not know why you're not getting the results that you want. Because I got stuck. For my case, I got stuck. I'm changing a different method, different technique, approach, but I still cannot get. Then I went to look into the formulas, theoretical. Then I try to change. I try to calculate back, insert the values. I try to calculate back. Then I understand. Okay, this is the issue. This is the real issue. So I need to modify that, modify the formula. Then I propose to them. Then only I can continue doing the design. Then after that I got my results, the results that I want. Okay, so that's the thing lah. Because why we need to analyze the data. Okay, the purpose of analyzing the data is to obtain usable and useful information, right? So you have to make sure that the results is correct lah. I mean, like that, use the results that can be used for improvement in later period. So the analysis irrespective of whether the data is qualitative or quantitative. To describe and summarize the data, identify relationships between the variables, compare the variables, identify the difference between variables, and forecast the outcomes. Right? So this is why we need to analyze the data. So for my case, I did some analysis on the data after doing a certain thing. So I tried different methods, different techniques, because I already have some plans. Initially, I already have some plans. Okay, if method A doesn't work, method B, I will try method B. If method B doesn't work, I'll try for method C. So when I try all the 3-4 methods, I still couldn't. When I analyzed the data, the results, I still couldn't get what I want to achieve. Then only I went back to the theoretical formula. Okay, theoretical formula. Then I really analyze, calculate back. Okay, I calculate everything. Then I identify. Okay, I need to modify the formula. When I modify the formula, then when I apply, then only I can get the results that I want. Okay. So you guys should have a very strong foundation lah. That's why you guys learn the theoretical in your bachelor's degree, right? The theories in your bachelor's degree, so that you guys understand the theory of your project. Okay, whatever you want to do. Okay, so scales of measurement. So many people are confused about what type of analysis to use on a set of data and the relevant forms of pictorial presentations or data display. So the decision is based on the scale of measurement of the data. So these scales are nominal, ordinal, and also numerical. Okay, so there are different scales of measurements for the data. Okay, so for engineering, we have a different approach lah. Later I'll show you. Right. So what is nominal scale? Okay. So nominal scale is the data can be classified into numerical or name categories. Okay. And the order in which these categories can be written and asked in arbitrary. So ordinal. So what is ordinal scale? So the data can be classified into non-numerical or name categories. An inherent order exists among the response categories. So ordinal scales are seen in the questions, right? That call for ratings quality. So for example, we'll have some feedback forms, right? So you guys have to choose very good, fair. So from 1 to 5, you'll have to answer the feedback form, right? So strongly agree, disagree. So these are the ordinal scales that used, okay, to collect the feedbacks, okay, data. Okay, so numerical scales, right? So where the numbers represents, okay, so that's where our usually for engineering we'll use these numerical scales usually. So where the numbers represent the possible response categories. So there is a natural ranking of the categories. 0 on the scale has the meaning. So there is a quantifiable difference within categories and between consecutive categories. So we can see some how to say uh, values. I mean, like we can identify, we can summarize the values of this. Okay, so that is called as numerical scale. Okay, so what are the common myths? What are the common myths that usually students they think? So the students always think that complex analysis. Okay, complex analysis. Your project should have complexity, but it doesn't should have a very complex thing. Okay, where you become complicated. I mean, like you will become very stressful with your complexity. Okay, you should know the complexity. You should identify the complexity. You should be able to identify your complexity. It's not that you cannot identify the complexity of your project. Okay, so it will be very difficult for you later on. All right, so this is like complex analysis and big words impress the people. So they think that when we do a very complex analysis and we use very bombastic words in your thesis, so it will impress the people actually, but actually it's not. Most people appreciate practical. Okay, most people appreciate practical and understandable analysis. Okay, it's not you do a very complex analysis and people doesn't understand what you do. Okay, so another one is analysis comes at the end after all the data are collected. So they think okay, so people will think okay, we have to do all, we have to collect, we have to complete everything, data collection, then only we have to do the analysis. So if your data that you collected is wrong, okay, so you have to repeat everything back, right? So instead of doing the analysis after collecting all your data, so you try to do in between. Okay, we think about analysis upfront so that we have the data we want to analyze. Right, so when you collect a small data you must be able to identify, okay, this is not the correct results or data that I want. Okay, the data is some like seems to be illogical, it's not logic at all. Okay, so this is what you guys have to think. So not like after collecting all the data then you do the analysis. Okay, so quantitative analysis is most accurate type of data analysis. So people also think quantitative analysis is the most accurate when you have when you show all the numbering things. Okay, when you show the graph with numbers and everything, so people think that oh, it is, people will say okay, this is the correct result or not. So something numbers are more accurate than words, but it is the quality. Okay, it's the quality of the analysis and process that matters. Okay, so don't think that okay, so when we give a very good graph with numbers, a lot of good numberings, you can say that my project is very good. Okay, so this is the quality of analysis. Okay, how quality is analysis, that is very important. So when using a quantitative methodology, you are normally testing theory through testing through the testing of a hypothesis. Okay, that is for quantitative methodology lah. In qualitative research, so usually we will not focusing on the qualitative. In qualitative research, you are either exploring the application of a theory or model in a different approach. So context or are hoping for a theory or a model to emerge from the data. So in other words, although you may have some ideas about your topic, you are also looking for ideas actually. So concept and residues often from the expert and practitioners in the field. So these are the things that you have to consider in your project actually. So you don't have to make a very complex analysis. So make sure it is practical. Your project is more practical so that people can understand your analysis, and also the data, the data you collected. You don't have to make it very complex analysis. Okay. Um, so try to be very straightforward with your results, so that people the reviewers, because whatever it is, uh, whether it is your paper, okay, journal or conference paper, or your thesis, someone will be evaluating. huh? Your papers journal will be reviewed by experts in the field, scientific community. Your thesis will be evaluated by your supervisor, by your panels. So you have to make sure that they understand what you want to present actually. what you want to actually say. So if you make more complex, so until they don't understand what you do, then it will become very difficult for you. Okay. So there are some other common myths as well, right? So means that data have their own meaning. So data must be interpreted. Okay. So when you collect the data's numbers, okay, so the data's will be in numbers, right? But by looking at the numbers, we don't know what are the results that we want actually. So that's why we convert the numbers, the data into graphs. Okay, so that we know. Okay, so this is what, let's say for example, this is temperature. This is temperature. This is location. Okay, or distance. So when we see, okay, so when we go this distance, then temperature increase or decrease. Okay, so there are some fluctuation in temperature. So that's thing like when you collect all the numbers, okay, temperature values, how you want to how you want to make the readers to understand. So when you turn into this graph, then okay, they can understand. Okay, so uh, this is what you want to analyze actually. Okay, so it must be interpreted. All right, numbers do not speak for themselves. So stating limitations to the analysis weakens the evaluations. So means that people think that okay, when we state some limitations in the analysis, so people think that it will be weaken your evaluation. It's not like that. All the analysis, all analysis have weaknesses. Okay, it is more honest and responsible to acknowledge them. So that's why we have scopes and limitations. As I told you just now, we have scopes and limitation for that purpose, because we have to make sure that we do the project. We do the project within your scope. Okay, so you can state your limitation. Okay, whatever limitations that available, you can just state, okay, these are the limitation of my project. I couldn't achieve these parts, okay, for this part in your project. uh, so the reviewers also, they will understand, because they know the scopes and limitations as well. Okay, so if they suggest, okay, you can try another method and see. So they will give some suggestions, right? It's not like they will see, oh, this is a very bad project or research project. It's not like that. Okay, you have to understand that all the analysis have weaknesses, so you have to acknowledge your limitations. Okay, so computer analysis is always easy and better. So something that computer analysis is always easy and better, but it depends upon the size of the data set and personal competencies. For small sets of information, hand tabulation may be more efficient, right? So these are the common myths people understand lah. Um, so they think that these are when we do a very complex analysis, okay, uh, our project will be very good. uh, so try to avoid that. Okay, try to have objective. Once you identify the objective, try to make scopes and limitations for your project. Okay, you have to, there should be some complexity in your project, but it shouldn't be more complex, much very complex, until the readers, they can't understand what you're going to do actually, what you're trying to do. Okay, so that's by stating the scopes and limitations, you can clearly identify, Okay, you yourself, you know, okay, I will be doing this project only within this limited limitations, within the scope only. Okay, so when in your data analysis or your analysis, you can state, okay, so since I'm getting this kind of results because of some limitations, I already set some scope, there are some limitations, that's why I'm getting this kind of results. Okay, maybe it can be for, like, say, for example, for electronic students, you guys are designing some circuits. Okay, so there will be some drawbacks, like so there will be some because when you fabricate your hardware, right, so there will be some errors on the fabrication. Okay, that might give some uh, results that is not that efficient. Okay, so you can say that, okay, because of this fabrication errors or issues, we are not getting the results as we want. So there are some fluctuations in the results. So you can say that. Okay, it's not wrong to mention that, right? uh, okay, so we'll take some small short break. We'll take some short break, then we'll continue back at 11:30, right? Okay, we'll continue back. Okay, so okay, so next we look into the tools, right? The tools that can be used to collect and present data. Okay, so just now we studied why we need, okay, why we need uh, why we need to analyze the data, right? Because we need to because once we collect the data, we have to discuss. So how you want to discuss using the raw data? Okay, so you have to um, uh, display in a graphical way so that the readers can understand. So tools to collect the data and also to present the data. So data can be presented in different formats that include tables, graphs, and narratives. So statistics is a tool that is used for quantitative research. Qualitative research uses non-statistical tools. So graph can be used to present both qualitative and also quantitative data. So usually we'll use the graphs, okay, to present the data, so the raw data, the results. Okay, so what are the types of graph and chart that available? So we have bar graph, we have pie chart, we have line graph, table, and also etc. So there are a lot of different graphs and charts that available that we can use to present the data. Okay, so this is the pie chart. For example, this is the pie chart that can be utilized. So for pie chart, we show only one category, okay, one data or data clearly. So it can show the percentage. Let's say, for example, this is the percentage of first quarter, second quarter, third quarter. So what are the percentage that achieved? So it can display only one data, okay, for this pie chart. Then we have a line graph. So for line graphs, we have x and y axis, right? So we have some values for x axis and so y axis, and also we have some values for x axis. So all data are related to each other. Okay, so it is related to each other category. Uh, and so we have different two categories, right? So here we have some one category and so another category here, used to show the minimum and maximum value. Okay, so from here we can see what are the minimum and maximum values that can achieved. Okay, so for the minimum we can see that this is the minimum point lah. For this is a maximum point. For example, here also same, this is the minimum point, and for the maximum point is here. Okay, so from the line graph itself we can see which one is the minimum and maximum, shows the increasing or decreasing trend. So you can see here it's like keep on increasing, right? So here you can see it increases and also then it drops. So it's not suitable for unrelated data. So it should be have some relations. For example, these two lines should have some relations between each other. Okay, so this is for line graph. So this is for bar graph actually. So bar graph we have uh, So it can be used for unrelated data. This bar graph can use for unrelated data, used to show maximum or minimum data here, and not suitable to show the trends. Okay, it's not suitable to show the trends. Like as for example, just now we have line graph. It shows the trend, right? You can see is like increasing or decreasing, right? But for this one, it's not suitable to use that bar graph lah. Okay, so you can have some different unrelated datas here. So this one is like projected international population. This is the projected international population for 2030, for example. So you can see like in 2003, this is how much. Okay, 7 million. On 2013, this is how much. Okay, so from here we can see, because it's like we have different countries for each year, right? For each year, so maybe country A have this much of population. Okay, country B have this much of population. So from here, you cannot identify whether it is increasing or decreasing. Okay, it's very difficult for you to identify lah. Okay, like for this one, you can say, okay, for this category, this for this one, you cannot say this is increasing or decreasing. For this one, you can say lah, it's like can see some increment, right, in the population. So this is what with bar graph actually. Okay, this is also another type of bar graph. So internet usage in Malaysia by age group. Okay, so you can see here different ages. We have less than 5, 16 to 30 years, 31 to 50 years, and also more than 50 years. So we have different categories. Also for each year, you can see how many the percentage of usage, internet usage, according to the age group. Yeah. Okay, so so this is the table, right? Okay, this is a table. So when to use the table, too many data category here, too large different in scale between data. So we have when we have too many data categories, so we can have this table. Okay, and also too large different in scale between data. So table is not suitable to show trends. Okay, it's not suitable to show trend, and also showing the minimum and maximum values. But from the table, you can have some from the line graph. Okay, like you can change this graph into this in table. Okay, chart with the data table. Okay, this is only for table only. Okay, from here you can only have some numberings to, it's like to summarize. Okay, is to like summarize whatever data. Okay, the maximum or minimum values. Let's say for example the line graph, this is the line graph, right? So we have maximum and minimum values. So you can take the values and put into this table, so that people don't have to see the graph. They don't have to see the graph to find, okay, where is the maximum value, where is the minimum value. Okay, they don't have to see the graph. Once they see the table, okay, they will identify, okay, this is this is the maximum value for this line graph, and this is the minimum value for this line graph. Okay, so this is the use of table, right? So this is like uh, can see that chart with the data table here, right? So you can see from here, from the chart itself, they converted into table, so that we can see directly. Okay, batch 1, so this is batch 1, blue color is batch 1, right? So batch 2 is 30, so batch 1 is 10, then batch 2 is 30. So when I look into this table itself, I can know the numbers. Okay, I don't have to look into this, oh, this is 30, then I look this and I see 60, when I see this and this is 40. So I just look at this, okay, batch 1 is 40, 60, very easy, right? So this is why we have it is more convenient for the readers, to identify the values from the graph itself, rather than looking into the graph and finding for the minimum and the maximum values of that. Okay, so so the ISAF, this is the BR. So this is an example graph. Okay, so BR, okay, bit error rates decrease as the number of simultaneous users increase. So when we convert into this table, okay, it is easy to identify. Okay, so this is like for FCC, DCS, MDW. So we put it. So what are the code weight and number of users? From here we can see number of users and percentage of number of users improvements. Okay, so from the table itself, I don't have to look into this graph, but this graph is these values are taken from this graph. You still have to show this graph, but in order to make the readers much more easier to understand your graph, so it is advisable to put a table, so that we can directly see the numbers rather than finding it here in the graph. Okay, all right. So let me show some example from my thesis. Okay, here so this is the graph, like, okay, from this graph is very difficult for you guys. I can understand. Okay, I can understand what is all about, because I'm the one who doing the project. Okay, but as a reader, or as an outside reader, so it is difficult for them to identify. So how you can make it more convenient for the readers, right? Okay, so from here, for this is the results. So what I make, so I make it into, I put it into table. Okay, I put it into table so that I identify the values. Okay, what are the resonant frequency, what are the Raynaud's gain, total efficiency, all these things, that it'll be easy um, for the readers, okay, for the reviewers or panels to understand the values, because they don't have to see here into these graphs. Okay, they just can refer to the table here, the values, because the values are the most important thing. because you will be explaining. You'll be explaining. Okay, I achieved this much of efficiency. Okay, so if you are inserted into the table, so it will be difficult for the it will be easy for the panels. Okay, so these are the examples where I use the line graph. I use my line graph here, uh, and also with table. Usually I'll do that lah. And so this is a polar chart. Okay, so from the polar chart, it's very difficult for you to identify what are the values, right? So I have inserted the table, okay, from here, so you can see the values, right? So rather than looking into these graphs one by one, what are the values, maximum, minimum values, I can just go to the table. But this is also you have to include this one also, because the values you got, the values you will be taking from this graph. Okay, so you still have to put the graphs in your thesis, but you just summarize the values, the important maximum minimum values, and in this table, so that we can see, okay, so this is the maximum value, maximum gain that you achieve, right? This is the minimum gain that you achieve in this angle. So we have angles, right? 360 angle. So at what are the maximum gain? At which angle you achieve that maximum gain? Main lobe. Oh, okay. At which angle? So I don't have to look into here. Okay. So this is what angle is this? What value is this? I don't have to look into this. So this is the way how you make your thesis much more convenient to read by the panels or reviewers. Okay, so you have to, while you do the your project. Okay, so you have to make sure what kind of tools, what kind of graphs it's suitable for your project. You have to identify from the beginning itself when you do the methodology. Okay, so that's why it's for methodology, the planning is very important. Okay, so planning for your project is very important, so you have to make sure what kind of method that you want to use. Okay, what are the data that you want to collect, how you want to analyze the data, and how you want to display the data. So this is very important, so you have to identify correctly before you start your project. Okay, so mm, so this is like a summary. Okay, so you have to make sure you don't do the according to the rubric that I showed just now. So you have to make sure that your methodology in the excellent part. Okay, in the rubric itself. So we are referring to the rubric here, right? So make sure you can achieve at least good research methodology. So if we can achieve this, so it can be considered a very good research methodology. Right. So I think that's all for today. So any questions? Any questions from you guys?
No, thanks, Doctor.
So I just want to know, are you? how many of you from? Yeah, I mean, what kind of projects that you guys doing? Like PointJ, I know because I'm his co-supervisor. So, how about Muhammad Shahid? Oh, Muhammad Shahid, sorry, left. Noor Azman.
Yes, Doctor.
Yeah. May I know what kind of project that are you doing?
I do the failure analysis. My topic is related to failure analysis for the related emission testing.
Okay.
Industrial topic, Doctor.
Industry topic. Okay.
Yes.
Okay. Thank you. So, how about Prabha?
I'm basically doing a deep learning AI-based project for computer vision tasks.
Okay. So, you're from which program?
Uh, Previously or currently?
Previously,
Microelectronic.
microelectronic. Okay. Right. So, how about Ismail?
My project basically was building a dielectric for a capacitor.
Okay. Dielectric for capacity. All right.
Yes,
So, from electronic engineering.
yes, I am from electronic engineering.
Okay. All right. Thanks. How about Lok Wei?
Yeah, basically it's IGBT for switching devices robustness.
Okay. All right. So, you're from which program?
Microelectronic.
Micro A. All right. Okay. Thank you. How about Wayu? Wayu Artanuka.
Yeah, yes, doctor.
Yeah. So, what kind of project are you doing?
Development of artificial neural learning for location prediction in wireless positioning system, doctor.
Okay. Wireless position. Okay. Neural network.
Yeah.
Okay. All right. Thanks. How about Nurul Iman?
For me, my project is about the sensor for detection of nanoplastic, which I use the silver nanoparticle deposited on silicon nanowire.
Okay. So, you're from which program?
Institute of Nanoelectronic.
Oh, okay. I knew. Okay. Right, right. Okay. Thank you. How about Mohammed Afizuddin? Afizuddin?
I'm from electronic engineering.
You're from
Doing electronic
electronic. Okay. What kind of topic are you doing?
boutique
What's that?
device.
I didn't hear you actually.
Doing
Okay, okay, it's okay, okay. No, no problem. I cannot hear you. Okay, it's okay, no problem. How about Arvin?
Hello, sir. My topic is about AI to detect the emergency vehicles.
Okay, all right. How about no Farid? Farida? Nur Farida? Okay, all right. Abdul Rahman, forward.
Yeah, doctor. I am doing vital signs monitoring using AI,
Okay, so you're from which program?
computer engineering.
Computer engineering. Okay, all right. Thank you. How about Lau Pei Hing?
Hello, sir. Hello, doctor.
Yeah.
I'm doing indoor localization for medical device.
Okay. So you're from biomedical, yeah?
No, computer.
Computer engineering. Okay.
Yeah.
All right. Thank you. All right. Fadzila? Fadzila, any?
Yeah.
So what is your topic?
On development of artificial intelligence model to determine the efficiency of SILA training.
What training?
Silat.
Okay. Okay. So you're from which program?
Biomedical engineering.
Medical. All right. Okay. Thanks. So,
Thank you, Doctor.
all right. Thank you very much. I hope today's topic has given you guys some introduction lah